good morning. Today we will discuss about binary search. So we have already implemented linear search. Now what I will do is I will take the same search.c file and I will put the binary search code here. So before binary search, the element should be in the sorted order. So one option is that we can call the user can call before calling the linear search or before calling the binary search, the user can perform the sorting or user can enter the elements in a sorted order. But all these are giving user a burden. We want to remove that. For that, what we will do is we will take the binary search code. So I have the binary search code. We'll first of all go through the binary search code. The simple code. So I have the array is there, size is there, element. The same as the linear search. Okay. So we will perform first equal to 0, last equal to size minus 1. Then we will try to find out the middle value. So I want to find out the middle value. Uh, again the same concept I will use. If the element is found, then flag value will be returned. If the element is not found, then I will return the corresponding flag value as 0. If somebody is asking, okay, I want to return the index of the array, then instead of returning flag as that particular value, if flag as 1, we can pass the index of the array. That's very easy. Okay, so we will take the example. Okay, if first is less than or equal to last, then we will find out the middle value. So while writing the middle value, most of the students may not be using this brackets. If the bracket is not used properly, then this will not perform the real output. So we have to use a bracket because addition should be performed first before division. So if we are removing the bracket, we will have a problem. The first addition will be performed later because multiple division has the highest priority. So we have to write like this. Then only it will work. Okay. So we will remove this one also. It's not needed. So we will find out if I will check whether the element is in the middle position. If the element is found, then I will return the flag value as 1. Then it will break. If the element is not found, then we have two options. We want to check whether that middle element is greater than the element to be searched. If it is greater, then it's clear that the element is in the left hand side only. Then what we can do is instead of searching the whole list, initially we set it first equal to 0 and last equal to size minus 1. We will move the last to mid minus 1. That means we will perform the searching from in the left hand side only. Okay. If it is opposite, that means mid value is less, then we have to search only in the right hand side. Then we will move first equal to mid plus 1. Okay. Same thing, I will return the flag value. Flag value will be returned. Now we have the problem because we want to perform the sorting algorithm. So what I will do is we will take this is a structure of a program. So we have the cycle 1, we have the searching program is there. Okay, so what I will do is I will create another cycle 2 where I have written the sorting code. Simply I have written a selection sort code. So we will go through this code. So selection sort, array is there, size is there. So we already discussed selection sort. What we will do, it will check each element, each position will be corrected. So I want to correct the first position, I equal to 0. Then what it will do, it will compare with the first position, second position, third position, fourth position, like that. So I will be compared with j. I value 0, j is I plus 1, that is 1. It will be compared. If it is greater, then we will perform swapping. Otherwise, we will come again. We will take third position value. It will be compared like that. So we will perform the selection sort algorithm. The simple algorithm is only there. We will come back. So what I will do is I will go to cycle 2 first of all. So I have the cycle 2 with me where I have the sorting program. I will just compile that minus C option. Then I will put a sort.c code. So what I will get is corresponding O file I have got. Now what I will do is I will take uh, this, I will write a sort.h file. So I have written a sort.h file. So sort.h file is there. What is content? Its content is simply the function declaration part of the sorting program. Okay, so I will just copy that. Okay, I have saved that. Now what I will do is I'm not going to give the source code of this C file. I'm just going to pass the .h file and the .o file to the cycle 1 because cycle 1 want to perform binary search, and if you want to perform binary search we need the list to be sorted. So what I will do, I will take these two files only. I have not taken, it's very, it should be understood. We are not taking the source code. We're only taking the object code and the .h file, and we are going to pass that to the cycle 1. So it's been copied. Now, what we will do is we will take the search.c file. So it's over. Now we will take the search.c file, and I will just simply include, I will just simply call selection sort before performing binary search. So if I want to call the header file, if I want to use the .o file, I have to include sort.h file. I have to include sort.h file. It's not needed. Header file is not needed because we are not using any printf here. So sort.h. I will just include sort.h file here. Then I will just save that. So now what happens is that when we are calling, the user is calling binary search, and the binary search code will code the selection sort, and it will sort the list, and after sorting it will perform the searching. Okay, so sort.h is ready. Now what we will do is we will just compile this code. Okay, I will combine this, come back. So we'll take the cycle 1 we will take, then we will perform the searching. Search.c is there, but I want to run before I don't have the header file, so I'll put a -c option here. So its O file is being executed. Now the code is being executed. Now I will take the run underscore search.c. The same code. This user is simply calling search.h. He want to use a search file. He don't think about sorting. Okay. The user simply called binary search. Okay. So the user is going to simply call binary search. So run underscore search.c. Then we actually the search. If we want to perform the searching, we have to pass the search.o file to be passed. But the binary search have to pass the sort.o file is also needed. So that is also passed. So two things we have passed, and we'll just run that. And we'll see what's output. So we have the elements. I have element 5, and elements is 10, 5, 9, 1, 6. Okay, element to be searched is 100. The same element is not found. I will check element whether element is there or not. 5 I will take, then element to be searched is 5, okay, 8, 9, 10, 1. Okay, element to be searched is 8. So element is found. So that's the concept of research.